the one I was going to do was the human cannonball, which is a nice one. And this happened at a show, in a Norfolk show in England. So I got a friend of mine to knock this up in Photoshop with a bit of standard background, and the man is in exactly the same position as he is in the real photograph, so that's great. All right, I'm going to do equal aspects. I want this to be real life. And okay, so I'm putting this so that this is on this axis. So I want a form for this equation that's going to work. This is a really nice bit of modelling to think about here. What's the shape of this going to be like? So it's certainly going to be what we call a sad quadratic, isn't it? Yeah, it's an upside down one, so it's going to have a minus x squared in it somewhere. So let's right click and enter equation, and let's do y equals, well, the minus x squared will take care of that, but we certainly need an a. If we just do a minus x squared, build this up slowly, just double x for x squared, by the way. What will that do? Well, if a is 1, that's going to produce a curve like that. Shall we do that? Okay, let's do it in stages, and I'm happy with the fast forward because I've already discussed what it's going to do. So we could get the constant controller now, and we could shunt it up to where it belongs, which is, and to see how nice it is, I can now reduce the step and go up a little smaller. I've probably gone too far now, but that's pretty good. Okay, 2.35. If I want to, I can select the graph and just put all this information up here. Let's get rid of that. Okay. That's okay, but now I want to move it out. So how do I do that without mucking up everything else? Well, the best way, of course, is to put parentheses here and put a b in here, and then x. That'll do nicely. But is that the best way? What does b represent? It might be better, actually, if we did a different form. But this is where it's good to discuss and come to different conclusions. But I think if you put the parenthesis here and do 1 minus, then also I think if I make it x over b, you can see I'm compressing a sort of 2-hour lesson into just a tiny bit. But now when x equals b, right, you're going to get a 0. So b will represent the distance along the x-axis, which is just what I want. So I'm going to click OK now. Nothing's going to change because b is 1. Okay, so nothing's changed except we now have the ability. But what we can do now is scribble all over this. Now again, watch out for this, because if you do this on an interactive board using one of their pens, what you've just scribbled will disappear when you come back to this program. It's just one of the flaws of interactive whiteboards. They're all the same, they've all got the same problem. So we've got our own scribble tool here, which means I can write b there and b there. So I'm now beginning to build up my model, which is going to fit this diagram quite nicely. Okay, so what do I do now if I change b? If I make b bigger or smaller, at the moment b is 1, and because of the model I've chosen, I think b is going to be bigger to make it go across here. So let's see, that is indeed the case. Or have I got the wrong page? That's page 5, that's the wrong. Got to get the right controller for this page, page 5, and we want b, here we go. Right, it's going to make it bigger, and that does indeed move it out. And you can see that the actual value of b is equal to the distance along the x-axis, because I've chosen an appropriate model. And I can take that all the way down to there. That's a pretty good fit, but you can see that what happens around about here somewhere, the guy decides that if he keeps on this path, he's going to land on his head. Not good news. So, and he starts to do some gymnastics and solves the problem that way. But it's a lovely example of a parabola. There are plenty more I can assure you.